Good morning, mathematicians, and welcome to Friday, the 22nd of January. We've made it through another week 3 of our new term. Let's start this lesson today. Let's be really positive. Let's finish the week with a high. Okay, let's begin with our quick quiz. We're getting used to these now, aren't we? 6 different questions from 6 different areas of maths for you to have a go at today. Okay, and in this morning's quick quiz, we have a question about fractions, of course. That's what we've been looking at this week. All right, so how many parts are shaded out of how many parts in total? And for those that can this morning, when you've worked out the fraction, this fraction can be simplified. So if you can simplify this fraction, divide the numerator and the denominator by the same number to create a simplified fraction, then extra fantastic. So see if you can simplify it. Secondly, we have a Carroll diagram where we can sort numbers. We have these numbers here: 25, 247, 7002, 49, 990. Now don't be put off by these. We have started to look at these in maths in the autumn term. Okay, we just need to sort these numbers into the correct boxes. Any of these numbers that are odd are going to go in this column somewhere. Any that are not odd, what do we call numbers that are not odd? That's right, they're even. Go in this column next to the odd one. Okay. But then we also need to factor in whether these are a 3-digit number or not a 3-digit number. For example, if I had an odd number that was 3 digits, it would go under odd and 3 digits. If it was an odd number that had 4 or 1 digit, it would go in the not a 3-digit odd number box. So have a think carefully. There are your 5 numbers. Can you put them in the correct place? Next up over here, again with our shapes knowledge, how many edges does a triangular prism have? Remember yesterday we looked at my fantastic little cube over here. Faces, flat faces you can draw a face on. Vertices, the pointy corners that we can put blue tack on, and edges, okay, where 2 faces join. Imagine standing on the edge. So we're thinking about how many edges does a triangular prism have? And just so you're knowing, a triangular prism is actually a Toblerone box. So you may have one of these left over from Christmas at home, or you may have a triangular prism box at home. If not, have a look at this picture here, and we're looking for the number of edges. So here's one at the top just to get you started. Okay, next up, think carefully on this one. Write the letters of all the shapes that are squares. I'm going to give you a hint here. There are 3, okay? And don't be fooled, okay, by shapes that are in different orientations. That means shapes that are presented in different ways, okay? So I have this square, for example. This is a square, even if it is held this way, or this way, or this way, it is still a square. So make sure you're looking very carefully. And if you have anything at all, like a ruler, having a look around here, like a ruler, okay, you can have a little look, because squares have 90-degree angles, okay. We can see, just like the ruler, there's a 90-degree angle here. There's 4 90-degree angles in a square. So you can actually line this up with the corner of the shapes to see which ones match up and line up and which ones are squares. There are 3 to find. Next up, we have a calculation here. Something equals 435, subtract 30. I'm sure we can do that one very quickly mentally. And lastly, we have a sequence here. You need to work out what this sequence is increasing by and what the last 2 numbers in the sequence would be. Pause the video now and give it a go. Right then, okay, I hope you've done really well. Well done for giving it a go. All right, let's go through the answers now. Make sure you mark in a different coloured pen or pencil, and don't worry if anything's incorrect, or if you didn't manage to have a go at something, write in the correct answers as we go through them. Okay, let's begin with our shape. here. So we had 3 out of 9 parts shaded. So that's 3/9. Give yourself a tick if you got that. Even better, well done if you managed to divide 3/9 by 3 so that our simplified fraction was a third. A third of this triangle is shaded in. So very well done if you got that. Our sorting question here with our Carroll diagram. In the first box, odd and 3-digit should be 247. Underneath that, odd and not a 3-digit, you should have 25 and 49. In not odd and a 3-digit number, you should have 990. And finally, in not odd, not a 3-digit number, 7,002. Excellent if you had a go at that one. Next up, we have 9 edges. Should we just count them together? We've got 1 at the top, 2, 3, 4. Then we've got 5, 6, 7, and the 2 along the bottom, 8, 9. So we have 9 altogether. Next up, the 3 shapes that are squares are A, D, and E. Okay, because all of them have right angles and sides that are the same length. Okay, next up we have 405 is equal to 435 subtract 30. And lastly, we had our sequence here. It was increasing by 4, wasn't it? We've got the 4 times table here. All right, so we've got 116 and then 120 is our missing numbers. Moving on then to today. Our learning objective is to identify factors of numbers. And this lesson is really going to build on our times table lesson that we had yesterday. Our 3 steps are, number 1, I can find factor pairs using times table knowledge. I can make mathematical observations and find other examples. And number 3, I can investigate a statement and give examples to prove it correct or incorrect. Okay, let's get started, shall we? So before we begin our first task, I'd like you to switch on and activate your maths brain. If it's not already warmed up, then make sure we have a really good think about this before we begin. There's some really key vocabulary that's going to help us to be successful today. Okay, and I'd like you to be thinking about what you know already about factors and multiples, because they will really help us. What do these words mean? Can you write down a meaning or give some examples? You can either do that by talking out loud to the computer screen or talking out loud to somebody else at home that you can discuss these ideas with. Okay, or you could just jot down your thoughts on the page. Pause the video now and give that a go. Brilliant. Okay, welcome back. Hopefully you've got some idea already of what these words mean. If you're unsure, don't worry. Let's go through them now really clearly and then see how they will help us in our learning today. So, a factor of a number divides into that number exactly. Okay, numbers that fit into another number perfectly. So in an example here, the factors of 12 are 1, 2, 3, 4, 6, and 12. So factors go up to the number itself, and all numbers have 1 as a factor. Multiples then. I always like to think of multiples as basically being in the times table of a number. So a multiple is the result of multiplying one number by another. For example, 3 times 5 is 15. So 15 is a multiple of 3 and 15 is a multiple of 5. You can also say that 3, 6, 9 and 12 are multiples of 3. So multiples essentially are just numbers in a times table. Okay, so another way of looking at this before we move on is here. If we look at this calculation, 5 times 4 equals 20. So in this example here, 5 goes into 20 exactly. So 5 is a factor of 20. 4 goes into 20 exactly. So 4 is a factor of 20. And 20, because it is larger than 5 and 4, it's in the 5 times table and the 4 times table, means that it is a multiple of 4 and 5. Now, when I think of multiple, I think of multiply. When I think of multiply, I think of getting bigger, increasing. So remember that multiples are larger. Okay, so 20 is larger than 5 and 20 is larger than 4. Okay, hopefully that's helpful. If you're still a little bit uncertain, you can go back and replay the explanation, okay, to see if it makes a little bit more sense. Other than that, move on with me now and let's see if we can understand it really, really well as we go through our slides and the modelling. Okay. Let's take a little look. One way of thinking about factors, which is our focus for today, is to think about arrays. And you may recognise this way of representing factors from previous learning in your maths. So let's take a look here, shall we? This array of counters, we have 6 counters by 4 counters. Okay. Now, what other arrays of 24 counters can you make? Can you pause your video now and see if you can draw them on your whiteboard? Okay, so all you have to do for this one is think about other ways that you could draw out 24 counters in an array. Okay, pause the video and have a go. Brilliant, welcome back. Let's take a look, shall we, and see how many other ways we could represent 24 with an array. Remembering that each column and each row must have the same number of counters. So the first example we had was 6 by 4. So 6 times 4 is 24. Another one you could have had is 8 by 3, because 8 times 3 is 24. You could have 12 by 2, because 12 times 2 is 24. And of course, you could have one long row of counters, because 1 times 24 is also 24. And this way of representing numbers is also really helpful for us when we're thinking about factors. Because when we think about having 24 counters, we have found the factors of 24, the numbers that fit into 24 perfectly in these arrays. So we can see here that 1, 2, 3, 4, 6, 8, 12, and 24 are all factors of 24. And 24 is therefore a multiple of all of those factors. So 24 is a multiple of 1, 2, 3, 4, 6, 8, 12, and 24. These numbers are called the factors. Okay, and just like we said before, these are numbers that will go into 24 without anything left over. They fit in perfectly, and usually they come in pairs, which we call factor pairs. Okay, it says write down the other factor pairs for 24. How many pairs are there altogether? That should say. Okay, there are 4 factor pairs for 24. Okay, 6 and 4, 8 and 3, 12 and 2, and 24 and 1. And I'm just going to show you now on the board how we would record those, okay, as our factor pairs. Here we go. So in today's lesson, you will also be finding factor pairs. So I'd like you to watch carefully to see how I'm modelling that. Okay, so you can then be successful when you have a go independently a little bit later. So first thing that we would do is we'd write the number that we're finding the factors for in the middle. And I like to circle that number. Okay, now it's really good when we're finding factor pairs to think about our times table knowledge and also to work logically, okay, step by step, because sometimes we can miss out factors. Let's start first of all with the number that is a factor of all numbers. What is that number? Yes, of course, it's 1. 1 fits into every single number. So we have 1, okay? I then think, what do I need to multiply 1 by to get 24? 1 times 24. So 1 and 24. Okay, now all numbers have 1 and also themselves as a factor, so that's something to remember too. Now, I want to find my next set of factor pairs. Okay, can you see how I'm matching these up together? So 1 and 24 are a pair. Okay, I'm looking for my next pair now. And I can see that from 1, it would be logical to think about whether 2 is a factor of 24. Now I know that 24 is even, so yes, it will be in the 2 times table. So 2, and I know already that 2 times 12 is 24. So I put 12 over here. And 2 and 12 are a factor pair of 24. I'm then going to pull out my next 2, they almost look like legs, don't they? My next 2 legs, and I think about my times tables. If you need a little bit of support with this, it would be fantastic for you to go back to yesterday's work and to take a look at your times table grid, because that will give you a really helping hand with finding those factors. So I know that 3, because 1, 2, 3, I'm working logically, that 3 times 8 is 24. So 3 and 8 are another factor pair. Okay, and I'm then thinking about other factors. Okay, other factors that I know in 24 using my times table knowledge. I've worked logically 1, 2, 3. So what do you think I'm going to put down next? Have a think to yourself. Think about what we looked at with the arrays earlier. Okay, this is just a quicker way of recording those factors. If you want to have a go at the arrays, that's great in today's task, but this is a really good way of recording it even more efficiently. Now, which one comes next? Of course, 24 is in the 4 times table. Okay, and what do we multiply 4 by to get 24? Yeah, that's right, it's 6, isn't it? Of course, 4 times 6 is 24. Now you can see that I filled up and around with all of my factor pairs here, making sure that they link together. And I can be very certain that I have found all of the factor pairs for 24 now, because if I look at the bottom here, I've got 4 times 6. Now then, the only other number, okay, that is between 4 and 6 is 5. And I can see already that 5 is not a factor of 24, because in my 5 times table, 5 times 5 is 25, not 24. So I can be certain that 5 isn't a factor, so I need to leave it out, and I just simply leave 4 and 6 there. So my factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24 itself. Okay, and we could also say that as having 1, 2, 3, 4, 5, 6, 7, 8. 24 has 8 factors. Okay, let's go back to the slides and move on, shall we? Brilliant. So how many factors does 21 have? Now the starting point here is to draw the different possible arrays for 21 counters. Arrays are a really good starting point here, okay, for thinking about factors. You may have counters at home that you could use, okay, if not, just with a bit of paper and a pencil, drawing out 21 counters. But remember, the sides have to be the same amount. Okay, so with our array for 24, there was 6 rows of 4 counters, or 4 counters multiplied by 6. Okay, so have a think for 21. Pause the video now and see if you can draw out the arrays. Okay, off you go. Right then, okay, we've paused there for a minute and you've had a go. Let's see, shall we? Okay, one way of representing 21 with an array is 7 by 3, because 7 multiplied by 3 is 21. So 7 and 3 are factors. Of course, the long one, we could have one row of 21 counters. So 1 and 21 are factors of 21, because 1 times 21 is 21. Okay. And in this case, that's all of the possible factors. Some numbers have more factors than others. And we can say that 24 has more factors than 21 because 21 has only 4 factors. Okay, in 1 and 21, 3 and 7. Okay, final one to practice now. Have a look at 16. Okay, there's something a little bit different about 16 that we're going to talk about. Okay, so have a little think now, draw out or use counters to create all the different arrays that you can for 16. Off you go. Okay, right, hopefully you've paused and come back again. Let's take a little look, shall we? Right, first of all, you may have found 8 by 2, arranging them in that way, okay? 8 times 2 is 16, so 2 and 8 are factors of 16. You could also have 4 by 4, because 4 times 4 is 16, isn't it? So 4 is a factor of 16. We could also have 16 by 1, that long line there, because 16 and 1 are factors of 16. 1 times 16 is 16. And in this sense, we found then that 16 has 5 factors, 1, 2, 4, 8, and 16. Let's just investigate a little bit further, because before it was talking about factors usually coming in pairs. That isn't always the case, and there are some numbers that have something a bit special about them. So let's take a look, shall we? So, get my rubber. Okay, right, so just found the arrays, which are helping us to find the factors of 16. Let's write 16 out here and look at how we can record the factors in the way that I was modelling to you earlier. Okay, we know we always start with 1 and the number itself. Okay, because every single number has 1 in itself as a factor. Now, 16 is even, and in the arrays, we found that we could create 2 by 8. Okay, 2 times 8 is 16. Okay, now then, we then worked out that we could have an array that looked like this. We could have 4 by 4. It's 4 by 4. 4 times 4 is 16. But I'm not going to record that as a factor pair. Can you think why? Why would I not do this? Can you have a think? Because this is sometimes a mistake that children make when they're writing out these factors. Why would we not have 4 and 4? Call it out to me. Okay, well done if you're thinking that actually we don't need to repeat a number. We can't count the same factor twice. So when we have numbers like this, instead of recording it as a factor pair where we repeat the number itself, we give this almost a tail. These factor pairs look like legs, don't they? And so we give these numbers a tail like this. Okay, and we just simply record 4. So we know, therefore, that 1, 2, 4, 8, and 16 are factors of 16, and that 16 has 5 factors in total. Okay, let's return to those slides and build towards your independent tasks this morning. There we go. And just like we were saying here, 4 is paired with itself. Okay, so we don't have to count it twice, we only count it once. Right then, let's just talk through your task and then you can begin. For step 1, okay, you will be given these numbers. So you've got 12, 20, 25, 8, and 30. Okay, and your job, working logically from 1 and the number itself all the way around to the other factors, you need to write in the factor pairs for these numbers. Okay, and if you look at this one here with 12, can you see there's two sort of square boxes here? This means that these numbers are a pair, the two circle numbers are a pair, and the two boxes down here are also a pair. Notice 25, there's one down the bottom. I wonder which number goes in here down the bottom. What times itself is 25? Have a think. So this is the first thing that I would like you to fill in. And just so you can be really sure and confident, here is the example that we drew up together on the board behind me. Okay, 1 and 16 are a pair, 2 and 8 are a pair, and 4 is all by itself because 4 times itself is 16. So have a go at these ones. Okay, and then if you're feeling up for a challenge, also part of step 1, okay, where we're finding these factors, we have some larger numbers. Okay, and again here the examples given where we're working logically. 1 and 32 are factors of 32, 2 and 16 are factors, 4 and 8 are factors. Now for these numbers, because they're larger, I wouldn't suggest drawing out your arrays. I would suggest using your times table knowledge. Okay, but what's really helpful is that for each number you know how many factors there are because they are already drawn out for you. Okay, right, let's have a look at step number 2. For this one, we're looking to make mathematical observations and find other examples. To be a really good mathematician, we have to be observant. We have to be able to spot things and notice patterns, okay, and then think about other examples that might fit the same pattern. So your task here is to find all the factors for these numbers in red, okay? And then I want you to think about what you notice about the factors, okay? So we've got 36, 49 and 64, okay? And also this challenge here for step 2 will mean that you need to draw out your very own factor pairs like I've shown you here, rather than using the ones on the sheet. So again, you're building up your understanding of this and your independence because you are now drawing out the factor pairs for yourself. Okay, and then finally in green, once you have drawn out those factor pairs, can you think of any more examples, okay, that have the same thing in common? And even better, do you know what these numbers are called? They're a very special type of number. 16 is one of them. We can see 36, 49 and 64 are all a type of number that has a name. So see if you can remember what that is or find out what that is. Okay, that's your step 2 challenge. Finally, step 3, I can investigate a statement and give examples to prove it correct or incorrect. Okay, so Selma here, good old Selma, she has said a bold statement here, year 4. Selma says, the bigger a number, the more pairs of factors it has. I wonder, do you think she's right? Do you agree with her? Explain your ideas. Okay, so for this kind of task, you can't just guess and say, yeah, absolutely, she's right. Selma knows what she's doing in maths. You can't just go and have a guess, okay? You need to investigate it, okay? A bit like a detective. You need to work out whether it's true or false, okay? And what I've suggested here is that you investigate with different numbers, small and large, okay? And if Selma is true, then you should notice that the larger numbers that you choose, let's say you choose, say, 48, 71, would have more factors than, say, 9 or 12, okay? I've suggested you might like to start with, say, 24 and 71. That might give you a good idea. And then I'd like you to complete this STEM sentence. Once you've had a look at the numbers, you've counted up the factors and you've seen which ones tend to have more, and whether the bigger the number, the more pairs of factors it has. Okay, so your STEM sentence then to complete after you've explained, or once you've explored this, is I agree or disagree with Selma because, and this is really important, give your reasonings and actually write down what you found out. Okay, give an example. So because when I found the factor pairs for this number, there was more than or less than this number. So Selma must be wrong or right. So really try to clearly explain. And just like in our writing task the other week, think it, say it, write it. Make sure that you're writing clearly, full sentences, full stops, great handwriting. You know what we're looking for in year 4. You know those high aspirations. Okay, so give that your best go. You also might like to use this stem sentence under this, I know this because, and then talk about the examples that you found. Okay, those are your 3 challenges. Pause the video now, work as well as you can through as much of that as you can. Okay, really try and stretch yourself and push yourself, okay, to understand this really well, to lay it out very clearly. Okay, and then whenever you've reached the point where you've done your best, okay, come back and we'll go through the answers together. Okay, off you go. Right then, you should have paused and had a good old go at this. I'm looking forward to seeing your work later. Let's now have a look at those answers. So I'm not going to read through these because that would take up a lot of video time, and you can just pause this video as soon as you're ready to mark these. Okay, this was the first sheet of answers, and this is the second sheet of answers. So pause the slide now and then mark in a different colour. Don't be afraid of being wrong, and really importantly, if you're missing any factors, okay, make sure that you jot them down so that you know them. Off you go. Okay, let's take a look at our step 2 answer. I decided to draw these out because I felt it was a bit clearer. Okay, so for 36, you should have found these factors, 49 and 64. Okay, again, you can pause this once I finish talking so that you can mark yours carefully. All right, and what you should have noticed here is that all these numbers have a factor that is multiplied by itself. Other examples include, I wonder if you found these ones, 81, okay, because 9 times 9 is 81, and 100, because 10 times 10 is 100. And very well done if you have worked out or researched or knew these types of numbers are called square numbers. Okay, square numbers, because when you draw out their array, 4 times 4, it actually makes a square shape. Brilliant. Okay, pause if you need to now to do that really careful marking, and then we'll have a look at step 3 if you got onto that. Right then, step 3. Okay, so in a nutshell, basically, no, Selma is not correct. Okay, it's not necessarily true that the larger the number, the more factors and pairs of factors it will have. Okay, and actually in this we could give that example here of some numbers which are called prime numbers. Now prime numbers only have 1, and themselves as a factor they only have 2 numbers as a factor pair. Okay, so you might have the number 24. We found that 24 had lots of factors, didn't we? 71 only has 2, and yet 71 is a bigger number than 24. So Selma is not correct. Okay, it isn't true to say that the bigger the number, the more pairs of factors it has, and we've proved that because 71 has less factors than 24, for example. Pause the video now if you want to read through carefully and make sure that you have everything marked really well. And of course, if there's anything incorrect or anything you could add onto your own ideas, then make sure you do that too. Right then, this leads me to the very end of our video. Very well done. We've made it through. We're at the end of another week. You've just got your English and your afternoon lessons to go through, and of course, your guided reading too. Let's take a moment now to just check, how have we got on today? How are you feeling about factors of numbers? And make sure you think about what you've been successful at, okay? How well you've presented it, how well you've worked through logically to find all of the factor pairs, okay? And then also think about, is there anything that you need to improve out, anything that you're not sure on, anything you don't understand? And it'd be really brilliant for you to email us with any questions or anything you're unsure on, or to use the Zoom session this afternoon to ask those questions, okay? And to see if there's anything that we can pick up on again in our maths sessions to make sure we understand it fully. Okay then, finally, don't go away without sending us your work. And here's a bit of a challenge. If you join us for the Zoom meetings, if you're watching this right now, it means you have access to the internet, and it means that you're able to watch these videos from the school website. That also means that you can send us your work. Because you have the internet and you have emails, you can then email, quickly take a photo of the work, get somebody at home, mum, dad, another adult that might be at home with you, get them to take a picture, okay, on their phone, quickly send it in to our email addresses, and we can take a look, and we always respond and give feedback. All right, so a challenge today: if you haven't sent your work in so far, start today, because we would love to see it. Really well done, mathematicians. Excellent stuff. We look forward to another fantastic week of learning next week. Have a wonderful weekend and a good rest. You take care.